Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your
OCR
exams
June
this summer.
2024, paper 1.
Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it.
Question 1. Write down an example of each of the following. An even number. Well, you've got lots to choose from, haven't you? I'm going to go for the number 2. Any number ending in 2, 4, 6, 8 or 0 will do. A multiple of 7, so a number in the 7 times table, I'm just going to go for 7. A cube number between 20 and 220. Well, the cube numbers are where you times a number by itself. First cube number, 1 times 1 times 1 is 1. Then we've got 2 times 2 times 2, which is 8. And then after that, we've got 3 times 3 times 3, which is 27. So that will do. That's in the range. And then a prime number less than 10. Okay, well, you can have the numbers 2, 3, 5 or 7. I'm going to go for 5 because I've had 2 and 7 already. So there we go, 5. Question 2, here's a list of 5 numbers, 10, 12, 4, 3 and 6. Write down the median. Well, the median is the middle one, but first we have to arrange them from smallest to biggest. So rewriting that list, I've got 3, 4, 6, 10, 12. And we've got 5 numbers. So to find the middle one, add 1, divide by 2, and that will tell you where the middle number is. So 5 plus 1 is 6, divided by 2 is the third number. Okay, so counting in 3, 1, 2, 3 is that 6 there then, isn't it? Okay, now with a small list like this, really this is a bit overkill. You can usually spot that's the middle one because it's the one in the middle, but on larger lists then that's a useful technique to know. Part B, a 6th number is added to the list. The range of the 6 numbers is 15. Work out a possible value for the 6th number. Okay, so if the range is 15, range is highest minus lowest. So the difference between those two numbers needs to be 15. So given that the lowest number is 3 and we want the difference to be 15, then the highest number is going to have to be 18. Okay, so it could be 18. Now alternatively, you could say that 12 was the highest number and 15 below that would be minus 3. So you could have minus 3 as well, but 18 kind of makes a little bit more sense. So I'm just going to go for 18. Question 3, part A, measure angle X. So I'm just going to put the protractor down on the angle. I'm going to make sure the center protractor is in the center of the angle where the two lines meet, and one of the arms of the angle is running down the 0 line of my protractor. And then it's just a matter of counting round till we get to the other angle, and this one goes round to 133. Use a scale that starts with 0 rather than the one that starts with 180, and you can't go wrong. So that's 133. Part B says angles of a triangle are 27, 126 and 27. Explain how you know the triangle is isosceles. Well, an isosceles triangle has two matching angles, two base angles that are equal, and this one has two angles that are equal, and so it must be isosceles. So it has two matching angles of 27 degrees. Okay, so it's got two matching angles, so it must be isosceles. Part D says the diagram shows two sides of a parallelogram drawn on a 1 centimeter grid. Part 1 says complete the drawing of the parallelogram. Include notation to show that the drawing is a parallelogram. Okay, well, parallelogram has two pairs of parallel sides that are equal in length. So drawing the one parallel to this one is 1, 2, 3, 4, 5, 6 units in length, isn't it? So if I'm going to draw one which is parallel, it needs to be 1, 2, 3, 4, 5, 6 units in length in the same direction. It should be like that, shouldn't it? Let me just draw that properly. Okay, so that's one pair of parallel lines. Now the other pair of parallel lines has to go, the other line has to be parallel to this one. But if I just join up the ends of my two lines, you'll see that it looks pretty parallel to me. So that looks right, doesn't it? So that one there is going to be my other parallel line. Now it says we need to include notation to show that the drawing is a parallelogram. Well, let's show that that side is parallel to that one and that side is parallel to that one. There we go. That seems to show it. And then it says work out the area of the parallelogram. Parallelogram areas is equal to base times height. So the base is just the length of this line along the bottom, which is 6 squares, and the height is going to be this distance here, which is 3, isn't it? So then the area of this shape is going to be 6 times 3 is going to be 18 centimeters squared. Question 4, here's the first 3 dot patterns in the sequence. So you can see it's kind of growing in 3 different directions, and we're adding an extra dot on the end of each line in 3 directions. So draw a pattern 4 in the sequence. So we're going to take pattern 3 and we're going to add a little bit more onto it then, aren't we? So I'm going to just repeat pattern 3 first. So let's draw pattern 3. So it's got 4 dots going down like that, and then 3 either side at the bottom. So that's pattern 3. Now to get pattern 4, we're going to add an extra dot on each of the ends, aren't we? Oh, sorry, I missed a dot off there. Should be like that. So that's pattern 3. And then to get pattern 4, I'm going to add an extra dot there, an extra dot there, and an extra dot there, like that. Okay, so that's pattern 4. So if, as you go from each one, like I say, you just add in those extra 3 on each time, aren't you? Okay, so that's what I've done here. I've added an extra 3 dots, and I've got pattern 4. And part B says, without drawing, work out how many dots are in pattern 10 of the sequence. Explain how you worked out your answer. Now, I could draw pattern 5, 6, 7, 8, 9, and then finally 10, but I'm just going to use something called the nth term to work out a way of going straight to that particular term. Now, we saw that these are going up in 3s, aren't we? This had 4 dots, this had 7, this has got 10, and this has got 13. Okay, so my sequence is going 4, 7, 10, 13. Okay, now for a sequence that's going up in 3s, that's very much like the 3 times table, which is 3n. 3n is 3, 6, 9, 12. But we've got 4, 7, 10, 13. If you think about it, each the one in my sequence is 1 more than the 3 times table. So if the 3 times table is 3n, then 1 more than a 3 times table is going to be 3n plus 1. So this sequence is 3n plus 1. That's the nth term. un is 3n plus 1. And what we want is u10, the 10th term. And that's going to be 3 lots of 10 plus 1. Because un, the nth term, you put n in there and then you can work out the answer. So if I want the 10th term, I put 10 in where the n is. And I just work that out, and that's going to tell me the value of the 10th term. So 3 times 10 is 30 plus 1 is 31. So they're going to be 31 little dots in the 10th term. Question 5, a teacher writes down a number, they subtract 6 from the number, and then they divide it by 8. The answer is 81. What number did the teacher write down? Okay, I'm going to do this algebraically. I'm going to say let the number that the teacher wrote down bx. Then they subtract 6 from the number. So x subtracts 6, and then they divide it by 8 over 8. And then the answer is 81. Okay, so that's going to give me the equation x minus 6 all over 8 is equal to 81. So what number did they write in down? I need to make x a subject of this. I need to rearrange or solve for x. So the first thing I'm going to do is I'm going to times both sides by 8. That's going to get rid of that number there. Leaving me with x minus 6 on the left. On the other side, I've got 81 times 8. What's that then? Well, 8 8s are 64. So 8 times 8 is 640. Plus another 8 is going to be 648. So that's equal to 648. And then add 6 to both sides. That's going to cancel. Leaving me with x on the left. And then on the right, I've got 648 plus 6, which is 654. So that's my answer. That's the number the teacher originally wrote down, so that when she subtracted 6 from it and then divided by 8, she got 81. Question 6. A playgroup offers 4 activities to their children. We've got baking, drawing, exercise, and reading. Complete the list below to show all the possible combinations of 2 different activities. You may not need all the answer lines. Okay, so we can't have baking because that's the same activity twice. They need to be different. So we can have baking drawing. We could have, which has already been done. We've got baking exercise, and we've got baking reading. So when I do these, I try to keep one thing the same and kind of rotate through the others. So I've done all the ones that begin with B. So I'm going to switch now to D. Now I could write DB, but that would be the same as BD. So that option is the same as the first one if you think about it. It's just the other way around. The net result is that you're doing baking and drawing. So order here doesn't seem to be important. So I'm not going to do DB. Can't do DD because I can't do the same activity twice. So I'm going to have to do DE next then, aren't I? DE. And then after that I can do DR. And I've done all the ones now that begin with D, so I'm going to switch to E. So EB I already did, ED is already done, EE I can't have, and ER is the only one still that's left to do. So that means there are 6 different combinations of 2 different activities. Okay. Now obviously if order was important, so if BD was a different one from DB, there would be a lot more choices, but here yeah, there are only 6. So write down the fraction of the combinations that include the reading. Okay, so how many of them have got a reading in them? Well, I've got a reading here, and I've got a reading here, and I've got a reading here. So that's 3 of them altogether that have got a reading. So how many combinations is that then? That is 3 out of a total of 6. So half of the combinations are going to have a reading in. I don't need to cancel it down though, I'm just going to leave it as 3 6. Question 7. This grid shows a vertical line going through the point P. Write down the coordinates of the point P. Well, coordinates are along the corridor up the stairs. So we're going -2 to the left and -3 down. So -2, -3 for that one. And plot the point 4, -1. So get rid of that. 4 -1 would be 4 along and -1 up. So that goes to there then, doesn't it? So that's my point there. Finally, write down the equation of the vertical line going through the point P. So any vertical line has the equation x is equal to, and what it's equal to is that value where it passes through the x-axis. In this case, it passes through it -2. So this is the line x equals -2. Question 8, here is a formula. A equals B lots of C plus D. Find the value of A when B is 3, C is 7, and D is 5. Okay, so we're going to replace the B in there with 3. We're going to replace the C in there with 7. And we're going to replace the D in there with 5. So that's going to give me A is equal to 3 lots of 7 plus 5. Just summing in for B, C, and D. Okay, now we need to do the maths. So brackets first, BIDMAS, think about BIDMAS, brackets before multiplication. So 7 plus 5, that's 12. So that's 12 times 3 we've got then. And 3 12s then are 36. So A is going to be 36. Then it says find the value of C when A is 30, B is 4, and D is 6. So again, I'm going to sub those values in. So I've got A is 30, so A, 30, is going to be equal to B, which is 4, open brackets, C, which we're trying to find, so I'm just going to leave that as C, and then plus D, which is 6. Okay? So here, we have to make C the subject, really. We need to rearrange it and make C the subject, or we have to solve for C, is another way of thinking about it. So the first thing I'm going to do is multiply out that bracket. So I'm going to multiply out this bracket. That's going to give me 4c plus 24 is equal to 30. Okay, then I'm going to take 24 off of both sides to get rid of that 24 over there. That's going to leave me with 4c on the right, and then 30 take away 24. That's 6. So then I'm going to divide both sides by 4 finally to get rid of that. And that will leave me with C is equal to 6 over 4, which is the same thing as 3 over 2 then, isn't it? So that's my answer. It's going to be 3 over 2, or 1.5. Could have with 1.5, of course, and that'd be perfectly fine. But I'm going to write it as a fraction, 3 over 2. Question 9. A bag only contains red counters and blue counters. 3/7 of the counters are red. There are 20 blue counters. Complete the table to show the fraction of the counters that are blue and the number of red counters. Okay, well, if 3/7 of the counters are red, then it makes sense that 4/7 of the counters then are going to be blue then, aren't they? Because 3/7 and 4/7 make 7/7, which is everything. So that means the ratio of red to blue are going to be in the ratio of 3 to 4 then, aren't they? Okay, so for every 3 red counters, you're going to have 4 blue ones. Okay, so in the ratio of 3 to 4. But we know that there are 20 blue counters, so under blue, I could rewrite that as 20. So if I scale up my original ratio of 3 to 4 by a factor of 5, I'm going to get 20 blue counters, aren't I? So if I do the same on this side times that one by 5, I'm going to get 15 red counters for every 20 blue ones. Okay, so I know then that to complete this then, so the fraction is going to be 4 over 7, and the number of red counters then is going to be 15. Question 10a. Write the ratio of 14 to 35 in its simplest form. Now you might notice that 14 and 35 are both in the 7 times table, so if I could just divide both of those by 7, I'm going to get 2 to 5 then, aren't I? So that's my ratio in its simplest form then, 2 to 5. Part B says the scale of the map is 1 to 25,000. 2 castles are 6 kilometers apart on the ground. Work out how far the 2 castles are on the map. Give your answer in centimeters. Okay, so if they're 6 kilometers apart, 6 kilometers, that's equal to 6,000 meters, then, isn't it? Because it's 1,000 meters in a kilometer. And then given that there are 100 centimeters in a meter, there must be 6,000 with 2 extra zeros, or 600,000 centimeters in 6 kilometers. So if I then want to know what the scale is of that on the map, I've got 1 to 25,000 is the scale. So if this one is 600,000, then in order to find it, how many times does 25,000 go into 600,000? I'm just going to do that as a division. So 600,000 divided by 25,000, that comes out to be 24. So I've scaled that up by a factor of 24 then to go all the way up to 600,000. So if I do the same thing on this side, then I'm going to get 24 goes with 600,000. So that means they must be 24 centimeters apart on the map. Question 11. Sam eats 30% of a 600 gram pack of cereal every day. Sam has no cereal left. The cereal is no longer sold in packs of 600 grams. Instead, the cereal is now sold in 400 gram packs. Sam wants to continue to eat the same amount of cereal every day. Work out the minimum number of 400 gram packs of cereal that Sam must buy to have enough for 7 days. You must show your working. Okay, so Sam eats 30% of 600 grams of every day. So how much is that then? So as a percentage, final, original, multiplier. So our final is what we want to find. The original is a 600, and the multiplier, 30% as a multiplier is 0.3. Okay, I'm just rewriting that as a decimal. So then the final is original times multiplier. So I'm just going to times those together. So it's going to be 600 times 0.3. So what's that? 600 times 0.3. That comes out to be 180 grams. So he noms 180 grams every day. So, and if he wants to eat those for 7 days, so over 7 days, that's going to be 180 grams times 7, isn't it? So just times that on my calculator by 7, that comes to 1,260 grams. So what's the minimum number of 400 gram packs he needs to buy? Well, number of packs is going to be 12,600 divided by the 400 in each pack. So if I divide that by 400, that's coming to 3.15. Okay, so he needs 3 and a bit packs. Now obviously you can't go and buy 0.15 of a pack when you go to the shops, so we're going to have to round that up, aren't we? We're going to have to round it up to four packs. So he needs 4 lots of 400 gram packs then to satisfy his cereal craving every morning. Question 12, increase £95 by 16%. Okay, so again, I'm going to do it with my triangle, final, original, multiplier. Put your thumb on it. Now, final is still the price I'm trying to find. The original is the £95. Now the multiplier, now it's an increase. So the £95 was the original. So, and then we want an increase of 16%. So what's that as a multiplier? So 16% would be 0.16, but I want to increase by 16%. Now, with these sort of percentage increase questions, we always start with 100%. So if I'm adding on 16%, that's 116%, which as a decimal is 1.16. So that's actually the multiplier that we're going to be using, 1.16. And so then the final is what we're going to get when we do what? Multiply those two things together. So final equals original times multiplier. It's going to be the £95 times 1.16. So what's that then? 95 times 1.16. That comes out to be 110.2. But this is in pounds and pence, isn't it? So that's £110 and 20 pence. They do often steal a mark off you if you get that 0 on the end. So just be aware of that. £110.20. Question 30. 50 students are asked how many books they have read this month. The table shows the results. So we've got number of books and the frequency that they were read. So let's work out the mean. Now to find the mean, we need to find the frequency times the number of books, fx, if this is x and that's fx over there. So we need to multiply all of these. 0 times 11 is 0, 1 times 8 is 8, 2 times 10 is 20, 3 8s are 24, 4 7s are 28, 5 6s are 30. So then once we've got all those, I'm just going to quickly add them up on my calculator. So 8 plus 20 plus 24 plus 28 plus 30, and that comes to 110. Okay, so then my mean is the total number of books read, which is 110, divided by the frequency of 50, which is the number of students, I guess. So 110 divided by 50, that comes out to be 2.2. Okay. Question 14. The machine makes 15 boxes in 12 minutes. The machine works continuously. Work out how many boxes are made by the machine in 7 hours. Right, so again, I'm going to do this as a ratio. So we've got boxes and time, haven't we? Okay, so it makes 15 boxes in 12 minutes. And I want to know how many boxes it makes in 7 hours. Now, minutes and hours are not quite the same thing. So the first thing I'm going to do is going to change that into minutes. Now remember, there are 60 minutes in an hour. So if I do 7 times 60, that comes out to be 420. So what I want to know is the number of boxes that are made in 420 hours. Okay. Now in order to do that, I just need to work out how many times bigger 420 is compared to 12. So 420 divided by 12, that comes out to be 35. So I've scaled up this ratio by a factor of 35. So doing it the same on this side, 15 times 35, that's 525. So that tells me then that in the 7 hours it made 525 boxes. I don't know if you've noticed, but ratio is my most go-to problem solving method so far in this paper, so it's really important that you're kind of really up on your ratios. It's very, very handy for GCSE. It comes up a lot. You could use it in lots of different questions. Question 15. The population of an island is 47,000 people. The area of the island is 560 kilometers squared. Calculate the population density of the island in people per kilometer squared. Okay, so for the OCR paper, you need to remember the formula for population density. So population density is equal to population divided by area. Okay, that's what you need to remember, so that when you get a question like this, you know what you have to do. So here, the population is 47,000 people, and the area is 560 square kilometers. So then the population density is going to be 47,000 divided that by that 560 then. So tapping that into the calculator, 47,000 divided by 560 comes out to be 83 and change. I'm going to write down 3 significant figures, I think. So 83.9 people per square kilometre. Question 16. A sports team scored 400 points. The defenders scored 1/10 of the points. The midfielders and the forwards scored the remainder of the points in a ratio of 1 to 5. Find the percentage of the 400 points that were scored by the forwards. You must show your working. Okay. So, looks like our sports team is broken down into defenders, midfielders, and we've got forwards. Okay. And of those 400 points, we know that the defenders scored 1/10 of those, so they must have scored 40. Okay, and then the other remaining points then were scored by the midfielders and forwards in the ratio of 1 to 5. So if the defenders scored 40, then the midfielders and defenders must between them have scored 400 minus 40. It must be 360 points between them. So then we need to divide that in the ratio of 1 to 5. Now 1 plus 5 is 6. So if we take 360 and divide it by 6, that's going to give us the value of 60. So then taking my ratio of 1 to 5, more ratios, can you see? Timesing it up by a factor of 60, that's going to be 60 and 300. So that means the midfielders would have scored 60 points and the forwards 300 points. So find the percentage of the 400 points that were scored by the forwards. So as a percentage then, that's going to be 300 over 400. Well, if I divide that by 4, I'm going to get 100 then, aren't I? So what's 300 divided by 4? 300 divided by 4 is 75. So that's 75 over 100, so that's going to be 75%. So that is what they scored then, isn't it? 75% of the points. Question 17. Triangle A is drawn on the grid below. Enlarge triangle A with a scale factor of 1/2 and centre of enlargement of 0, 0. Okay, so this is an enlargement question, but actually we've got a fractional scale factor of 1/2. That means my image is going to be half as big as the original object. So it's not so much of an enlargement as it is a reduction, but we still in maths call these enlargements, even if they end up getting smaller. So we're expecting our image to be half the size of our original object. Now we're told that the centre of enlargement is at 0, 0. Okay, so what you can do is you can measure the distance between the centre and each of the coordinates, or the corners of your shape, the vertices, and then multiply that distance by 1/2. So for instance, if you have a look at the distance from the origin to this bottom corner of the triangle, can you see it's like 4 units along and 4 units up? So in this direction, 1, 2, 3, 4, 1, 2, 3, 4. Now if you halve that distance, it's going to be 2 and 2. So that means the image of this point is going to be at that point there. Okay, half the distance from the centre of enlargement to your object. Okay, I'm going to do that the same thing with the other points. So picking the next point, the tip of this triangle, just draw a line between them. Now how far is it along that line from this origin to that point? So counting, that's 8 along and 6 up, isn't it? So if I halve that, 8 along will be 4 along, and 6 up will be 3 up. So 4, 3 is going to be halfway. It's going to be there. And then finally, I've got this point. So again, counting the distance, that's 8 along and 4 up. So if I halve that, it's going to be 4 along and 2 up. So you can see my little triangle has kind of formed itself there. So let's just join that up. There's my little triangle there. So that's my enlargement there. So you can see my triangle end up actually getting smaller than it did, not bigger. Question 18. Solve 7x minus 3 is less than 11. Show your solution on the number line. Now this is an inequality. Now actually inequalities solve pretty much the same way as normal equations. So if you had 7x minus 3 is equal to 11, would you know what to do? Well, I would probably add 3 to both sides. Cancel those. Leaving me with 7x is equal to 14, and then we'd be dividing both sides by 7, wouldn't we? Classic solving an equation. So that's going to be x is equal to 2. But this is not an equation, it's actually an inequality. So those equal signs should actually be less than signs. Okay? But other than that, it's exactly the same as what we just did. So our solution is x is less than 2. Okay, now how am I going to show that on the number line? Now, because it's less than and not less than or equal to, I need to show an open circle here. Now, if it was less than or equal to, I'd be shading that in and doing a filled circle, but it isn't, so I'm not. Okay, it's an open circle. And then I want the values that are less than that, which are the values off to the left. So I'm going to draw an arrow going off to the left. And draw a little arrow on the end like that, and that's how I show it on the number line. So an open circle at 2 and an arrow pointing off to the left. Just to help you if you're struggling which direction, it's normally the same direction as the inequality symbol. That's the way the arrow is going to go. Work out the cube root of 19.5 to the power 4 minus 18 squared all over 1.45. Write your answer correct to 4 significant figures. So this is just a use of calculator question. So you just need to get the order right that you type into the calculator. I'm going to use the cube root key first, and then I'm going to press the fraction key, so I've got the structure ready to put all those numbers in. Then I'm going to type the 19.5, raise it to the power 4, come out of the power and put the minus key, hit the minus key, and then 18 squared, and then the down key to go down to the bottom box, and I can type in 1.45. And I'm making that 46.337. I need to round it off to 4 significant figures, so I'm going to have to round off after the 4th digit. Now with these sorts of questions, it's usually a good idea just to write the full calculator display down first, so the examiner knows that you've got the right answer from your calculator. So I'm just going to quickly do that. And then I'm going to round it off. So the 4th significant figure, 1st, 2nd, 3rd, 4th, I'm going to round it off after that. 3, next digit is a 7, so I'm rounding it up, aren't I? So my final answer I'm going to give is 46.34. Now, as I say, it's a good idea to write your number down, because even if you typed it in incorrectly and didn't get the right number, there's still a mark available for you rounding off properly. So if you'd just written any old number down there and rounded off correctly to 4 significant figures, you'd pick up one of the 3 marks, even if you made a mess of actually typing it in. Yeah, so write down the full display and then round it off for your final answer. The diagram shows a triangle and a trapezium. Show that they have the same area. Well, the area of a triangle is half base times height, isn't it? So just subbing that into the formula. Half times the base is 18, look, so that's going to go there, and the height is 6.4. So subbing those values in, half times 18 times 6.4. So half of 18 is 9. I'm just going to type into my calculator 9 times 6.4. And that comes out to be 57.6. Next up, we've got a trapezium, and the formula for a trapezium is a half times a plus b, which are your 2 parallel sides, times h. Essentially what you're doing is you're averaging out your 2 parallel sides, and then you're multiplying it by the distance between them. So your 2 parallel sides are this one, 15 and 9. Okay, so they're the ones that go in the bracket. So that's half of 15 plus 9, and then we're going to times it by the distance between them, which is this 4.8 here, isn't it? Times 4.8. Okay. So I'm just going to do a little bit of this in my head because I think that's easier. 15 plus 9, that comes to 24, and halving it is 12. So the average of 15 and 9 is 12. So that's the same thing as 12 times 4.8. Okay, if you can do easy maths in your head and make typing into the calculator easy, I think that's worth doing. You know, key and errors are a thing. So if you can reduce the complexity of what you're writing, then you know, you're less likely to make mistakes. But look, we found that they're the same. Okay, they're both 57.6 centimeters squared, centimeters squared. A school is deciding on a charity to support. Each student at the school votes for one of 4 charities, A, B, C, or D. The results are to be shown in a pie chart. This pie chart shows the sector for charity A. Twice as many students voted for charity C than for charity B, and twice as many students voted for charity D than for charity C. Show that the sector for charity B will have an angle of 44 degrees. Well, let's just do a quick ratio here. B to C to D. I'm going to start with B. I'm going to give B 1 share because all the others build off of it. And then we know that twice as many students voted for charity C than for charity B. So twice of 1 is 2. And we know that twice as many students voted for charity D than for charity C. Then twice 2 is 4. So that means that B and C and D are in the ratio of 1 to 2 to 4. So altogether, that is 1 plus 2 plus 4. That's 7 parts, isn't it? Okay. Now, we know that 52 degrees is for A, so that means that B, C, and D must share the rest there, mustn't it? So what's that then? So 360 minus 52, that leaves us 308 degrees to share between B, C, and D. So we need to divide 308 in the ratio of 1 to 2 to 4. We already know that there are 7 parts. So 308 divided by 7, what's that then? 308 divided by 7, according to my calculator, that's 44. So then taking the ratio of B to C to D in the ratio of 1 to 2 to 4, and scaling that up by a factor of 44 then, so timesing everything through by 44, I'm going to get 44 degrees, 88 degrees, and twice 88. What's that? 176 degrees. Okay, so they're my three angles that I would need to draw if I was going to draw this pie chart. It says show that the for part A though, it says show that the sector for charity B will have an angle of 44, which we've done. So B equals 44 degrees there. Okay, so I've done that. Now we just need to draw it. Okay, so it's time to get your protractor out. Now it tends to be that practical skills like this are very poorly answered by students because when they're doing their revision, they can never be bothered to go and get their equipment. So don't be one of those people. Go and get your equipment, get your compass and your protractor, have them handy when you're doing these past papers. So you need to lay your protractor along the second arm of the lower arm of angle A, count round to 44 degrees, do a little mark, and then remove the protractor, and then use your ruler to draw the line in. So that's my angle for B. So that's section B. And then my next angle is 88 that I need to draw on. So again, I'm going to put the protractor on the lower arm of B and count round 88 and then draw a mark. So that's C. And then finally, the last one kind of draws itself then, doesn't it? That's 176. So that's my D section there. And then part B says 39 students voted for charity A. Calculate the total number of students at the school. Okay, so if we've got like another, I'm going to use another ratio here, students to angle U. So students to angle, then that was 39 students are represented by 52 degrees on the pie chart then, aren't they? And we want to work out the total number of students at the school. So that would be an angle of 360 degrees, wouldn't it? We need to get down to 360. So I'm going to use the unitary method. I'm going to go via 1. So to get from 52 to 360, we're going to divide both sides by 52, and then we're going to times both sides by 360 and see what we get. Okay, so I'm going to do 39 divided by 52 first. Apparently that's 3/4. I'm just going to write that down. Or 0.75 if you'd rather. And then I'm going to times that by 360 and then see what I get. So that's 270. Okay. So how many students are there altogether? There are 270 students. Part C goes on to ask the school asks 80 of the students to choose a new logo from 3 designs, G, H and J. The same results are shown in the pie chart and in a bar chart. Part 1 says give one advantage of using the pie chart rather than the bar chart. Well, I think the pie chart gives you a good visual demonstration of how big each section is. I think it's it makes it very easy to see that G is the biggest and it's bigger than the other two combined. Things like that. I think it's quite a visual way of getting a good look at the data. So I'm going to say the pie chart gives a good visual representation of the proportions. Okay, so you can see that G is proportionately bigger than the other two, which is not quite so obvious from the bar chart. And then give one disadvantage of using the pie chart rather than the bar chart. Well, the pie chart doesn't give you any values, does it? If you look at the bar chart, you can read off the frequencies, can't you, for the various bars, whereas the pie chart just gives you the proportions. So I'm going to say you cannot read the actual, what was it, numbers of students from the pie chart. Okay, so the pie chart gives a good visual representation of the proportions, but you cannot read the actual numbers of students from the pie chart. There are my 2 reasons. The same dog food is sold in 3 different sized packs. The diagram shows the price of each pack. So I've got 700 grams for £7.70. I've got 3 kilos for £32.40. And I've got 5 kilos for £53.90. Which pack is the best value for money? Show how you decide. So with these best value questions, you must have the same amount of each and in order to compare the prices. Okay, so you can either go smaller, you can divide them down to a smaller number that goes into all of them, or alternatively, you can scale them up. So you can make them bigger, and so you can find like a common multiple of those. So you either need a common factor or a common multiple. So one thing, if you've got a calculator, it's easy enough to find like 1 gram of each of those, but if it's a non-calculator, often then scaling up is better. So if I ever think about this, 700 grams, 3 kilograms and 5 kilograms, I think I'm going to just go for 1 kg of each. Just going to work out what 1 kg each of each one of these is, otherwise I'm going to get a kind of too small another. So how much is 1 kg for 1 kg of each of these things? So for 1 kg, first one is actually the hardest. I'm going to do the other two first. They're quite straightforward. So 5 kilos for £53.90. So divide £53.90 by 5. What am I going to get? I'm going to get 53.9 divided by 5. That's going to give me £10.78 per kilo. 3 kilos cost £32.40. So if I divide that by 3, so 32.4 divided by 3, that's going to give me 10.8 or £10.80. And then finally, 700 grams, I'm going to have to scale that one up a little bit, aren't I? So if I divide it by 7, I'll get 100 grams. And then if I times it by 10 after that, then I'll get a kilo, won't I? So 7.7 divided by 7 times by 10, that comes out to be 11. Okay, so we can see from that then that the 5 kg bag is marginally cheaper. Okay, so which pack is the best value for money? Show you how you decide. It's the 5 kg pack because it works out to be £10.78 per kg, whereas the other two are £11 and £10.80 per kg. Okay, seems to be a good enough reason to me. Question 23, a garage is 5 meters long, correct to the nearest meter, and a car is 4.5 meters long, correct to 1 decimal place. Show that the car may not fit in the garage. Well, if you look at it straight up, 4.5 meter car, 5 meter garage, you'd think it would fit, but this is a limits of accuracy question because we're told that this one is correct to the nearest meter and this one is correct to 1 decimal place. So whilst that garage is 5 meters to the nearest meter, it might not actually be 5 meters in length. Okay, so let's have a think about the limits of accuracy for our two quantities, our garage and our car. Let's take the garage first off. I'm going to draw a number line and I'm going to mark the value that they give us, which is 5. Now this is correct to the nearest meter, so if I was doing a number line with meters on it, the next meter up would be 6 and the one before it would be 4. And the values that would round to 5 would be the ones that were halfway between those or closer, wouldn't it? It'd be like that range. Okay, so halfway between 4 and 5, that's 4.5. We call that the lower bound. And halfway between 5 and 6 is 5.5. We call that the upper bound. So all the values between 4.5 and 5.5 would actually round to 5. So the garage could be anywhere in that range. Okay. Now the car, we're told, is 4.5 meters long, correct to 1 decimal place. So again, if I draw a number line and I mark on 4.5, then 1 decimal place above that would be 4.6 and one below it would be 4.4. So then the range of possible values for the car are going to be halfway between those or closer to 4.5. So halfway between 4.4 and 4.5 is 4.45, and halfway between 4.5 and 4.6 is going to be 4.55. Okay, so the car could be anywhere in that range. So can I show that the car may not fit in the garage? Well, I think I can, because if the car is down the lower end, down this end, if it was somewhere like here, somewhere, you know, we just know the garage is somewhere in that range. So if we know that the garage is down there by 4.5, and we know that the car is towards its upper value, up like that end of its range up here, then, you know, big car, small garage, the kind of the higher end of the car range is going to be bigger than the lower range of the garage range. So we could have the garage be 4.5 meters and the car be, well, I'm going to write 4.54 because strictly speaking it would have to round up if it was 4.55. So I'm just going to write 4.54 meters, and that's bigger anyway, isn't it? So the car would be bigger than the garage. Okay? And I suppose we should say it would not fit. So it may not fit. Okay? So we've kind of shown it, haven't we? So that's one of the weird things about limits of accuracy. Question 24. The diagram shows a straight line crossing two parallel lines. Find the value of y. You must show your working. Okay. So what have we got here? So we've got angles in parallel lines. So when you've got like two parallel lines, which we've got here, look, 1, 2, and a line crossing them, boom, then a number of angles are created. We get a bunch of acute angles here, 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 and here, which are all equal to each other, and we get a bunch of obtuse angles here, 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 and here, which are all equal to each other. Okay, so what we know is that this y down here, look, it corresponds to this angle up here. These are the same, and it's vertically opposite of the other one there. So we know that y is equal to 2x plus 50. Those two things are the same. Okay, but we don't actually know at the moment what 2x plus 50 is, because we don't know what x is. But we've also got two angles that involve x, and when they lie in a straight line, so we know that these two add up to 180 degrees. So if I take the 2x plus 50 one and I add on the x minus 14 angle, it should add up to 180 degrees because they lie in a straight line. So collecting like terms, I've got a 2x and an x, and I've got a 50 and a minus 14. So the 2x and x is going to give me 3x, and the 50 and the minus 14 is going to give me 36. So 3x plus 36 is 180. So then taking 36 off both sides, it's going to leave me with 3x. 180 take away 3x, what's that? 144. And then, so to find x, I'm going to have to divide it by 3 then, aren't I? So divide by 3, divide by 3, give me x, and 144 divided by 3, what's that then? 3's into 120 go 4 times, it's going to be 40 something, and then 3's into 24 go 8 times. So isn't it, I think it's 48. I want to double check that on the calculator, but I think it's 48. 48, 96, 100, yeah, that's right. So it's 48. So then sub in, so now I know that x is 48. I can write it in there, look, where the x is, and I can find the value of y out now. So y is 2 lots of 48 plus 50. So 2 lots of 48, what's that? That's 96, and 96 plus 50, that's going to be 146. So y is going to be 146. Question 25. The diagram shows a trapezium. Work out the value of x. Now that is the slant height of this trapezium. So how are we going to work that out then? Well, I guess if I divide it up like this first, then then because that's 12, then that is also going to be 12. So then this part is going to be the difference between 12 and 20. So that's going to have to be 8. 8 in that direction. And we know that this distance here is 15. So that's also 15. Okay, so then I've got a right angle triangle where I know two sides and I want the long side. So this is a job for Pythagoras Theorem, isn't it? C squared equals a squared plus b squared, except I don't have c here. I've got x, so x squared is equal to 15 squared plus 8 squared. Subbing my two numbers in. 15 squared is 225, isn't it? 15 times 15, yep, 225. And 8 is 64. So adding those together, that gives me 289. So 289. And if I want x, then I'm going to square root 289, and aren't I? So root answer, that's 17. So x is equal to 17. So my value of x, 17. Question 26. Solve the simultaneous equations 4x minus y is equal to 24 and 2x plus 3y is equal to 26. Now, when you've got linear equations like this and you want to solve them simultaneously, the easiest way is by elimination, and to do that you need to try and get two of your values the same. Now my 4x and 2x are different and my y and 3y are different, but if I multiply one of the equations up so it matches the other one, then I can go ahead and eliminate. Okay, now I'm going to call this one equation 1 and this one equation 2, and what we want to do is we want to take 3 of equation 1, multiply it up by a factor of 3, and then I'm going to get 3y that I can match up with the other 3y. I could have also doubled the other one. I could have doubled 2 and got 4x and 4x, but that would have involved some trickier subtraction of negative numbers, so I'm not going to do that. I'm going to multiply up 1 by 3. So 4x times 3 is going to be 12x, minus y times 3 is minus 3y. 24 times 3, what's that? 3 20s are 60, 3 4s are 12, that's going to be 72. Okay, and then the other one just stays the same. So I've got 2x plus 3y is equal to 26. Now notice the signs are different for the minus 3y and the plus 3y. So if I add them together, these two equations, then those two will just cancel each other out, won't they? The negative 1 plus the positive 1 will give you back down to 0. So 12x and 2x is 14x, and 72 and 26, well, that adds up to 98. So I've got 14x is 98, so x then is going to be 98 divided by 14, and according to my calculator, that comes to 7. So x is 7. Now, we still need to find y. So how we're going to do that is going to substitute x is equal to 7 back into one of our original equations. I'm going to go with the second one, I think, because I don't know why. I just fancy doing that. So I'm going to sub x equals 7 into the second one. So 2 lots of 7 plus 3y is equal to 26. Well, 2 7s are 14. So then subtracting 14 from both sides, they'll cancel, and that's going to give me 3y is equal to 26 take away 14 is 12, and then divide them through by 3 then. They're going to cancel, leave me with y is equal to 4. Okay, so I've got x is 7, y is 4. Now I could just check that before I move on. It's quite a nice easy check. We just sub both numbers back in and just see if it's true. Now I use equation 2 to find y, so I'm going to sub them both into equation 1. So 4 lots of x when x is 7 minus y when y is 4, is that equal to 24? Let's just double check. So 4 lots of 7 is 28, 28 take away 4 is 24, so that does work. Okay, so my check worked out fine, so I'm pretty confident that that's the correct answer. Better to know in the exam than when your results come back that you got that one wrong. I'm going to write down the following in order of size, smallest first. I've got 0.2, 2 to the power of minus 2, and 2 times 10 to the minus 2. Okay, well, 0.2 I know, it's just 0.2. What's 2 to the minus 2? 2 to the minus 2 is 1 over 2 squared, isn't it? Because a negative index is the same thing as 1 over that positive index. And 2 squared is 4, so that's a quarter. And a quarter I know is 0.25. So that one's 0.25. And what about 2 times 10 to the minus 2? 10 to the minus 2 means 2 zeros in front of your mantissa, which is 2. So I'm going to write 2 zeros in front of my mantissa, 0.0, and then I'm going to write the 2 on the end like that. So 0.02. So that one is 0.02. So that one is the smallest then, isn't it? So the smallest then is going to be the number in standard form. And then the next biggest is going to be the 0.2. And the biggest one of all is going to be the 2 to the minus 2. Like that. All done.
Mr. T, he's the best. Helps you ace every test. Maths worries now.